Estimating population mean, example number 2. All right, we'll just keep building out these flow charts. You have the full version of the flow chart. I just want to do an example that would lead us to the different scenarios that are here. But once again, we're supposed to find a confidence interval for a mean. All right, now it says here that in a study of 20 math professors, the average time it took to grade a paper is 8.6 minutes. I hope you would agree that that 8.6 minutes would be the mean of a sample, otherwise known as X bar. All right? So that would be something we could identify here. If we're going to find a confidence interval for a mean, 90% confidence interval for a mean, then I would suggest to you that you would go to the handy dandy flow chart. I want to tell you that I built this flow chart. I took 2 sections of the book and put them on one slide. So this half of the flow chart is one section of our textbook, and this half is another section of our textbook. In my experience in the past, students were having trouble as to which section of the book it was, so I put them together into one place, and there it is. It all hinges on standard deviation as to whether it's from a population or a sample, all right? So, I don't teach reading. This is going to sound snobby, but determining whether your standard deviation came from a population or a sample. Here's the words. Skim the problem. Look for the 2 words, standard deviation. Okay? And when you find them, read that sentence that has those words. So here's standard deviation. And I'm backing up until I get to the beginning of that sentence. And here we go. Find the 90% confidence interval for the mean for grading papers when the standard deviation for all papers, standard deviation for all papers, population, all papers, standard deviation for all papers. I don't know. How do you teach reading? You yell. I don't know. Okay? But all papers would be a population, wouldn't it? Not just a small group of papers, not the 20 papers that they sampled, all papers. Okay? The thing is, there is reference to a sample in this question. Yeah, you're always going to take a sample when you're going to estimate something. But did the standard deviation come from that small sample of 20 papers or all papers? That's the question. It said all papers. That's population. Okay, so we're still over here. Does it say anything about the population being normally distributed anywhere in this question? I would just tell you to read it if you get to that question, read it and look for the words normally distributed. We'll make it easy there. When that issue is in part of the problem, look for the words normally distributed. Okay? I'm reading, you're reading. We're reading example 2. I don't see anything about being normally distributed. I don't. It doesn't say those words. It doesn't say that it's a bell curve. All right? No. Doesn't. Does not. Okay? So here's the deal. Since it did not mention being normally distributed, we have to check our sample size to see if it's at least 30. Read the question again. How big was their sample? 20 math professors. That's less than 30. All right? And so, again, I keep flipping back and forth between the question and the flow chart. Is in graded? No, they only sampled 20. That's not more than 30. We can't say yes to that question. So, no. And so, use non-parametric or bootstrapping methods. Those are methods that don't belong in an introductory, and anybody would tell you, in an introductory statistics class, you don't talk about non-parametric or bootstrapping methods. At least it's not required for me to cover it. So the point is, you wouldn't know how to do this question. You would learn how to do this question, those methods, in a future statistics class, if you move on and take more stats. So, what is the answer that we want for this question? That phrase, use non-parametric or bootstrapping methods. Okay? In other words, you're acknowledging, I don't know how to do this yet in my life. I will learn those methods someday in the future. So write that down, that's the answer. All right? So there's no number crunching for us to do in elementary statistics. Write that down. That's the answer. If the question follows that particular path. There's example 2 for you.